Hello guys, so this is our class for today. You are welcome. This is Noble Mind Science Tutors Online, and this is our physics tutorial. Today we'll be looking at wave motion. We'll be looking at wave motion, and I remain Notable Michael. And please, before I go on, if you have not subscribed to this channel, please click on the subscribe button, click on the notification bell, so that when we upload a new video, YouTube will notify you. And as I've always encouraged, please get your writing materials. You can pause it now. Get your writing materials, your calculators, your pen, your biro, and all that, so that you can flow along as the lecture progresses. So today, as I said, we are going to be looking at wave motion. Okay, we're looking at wave motion, and on this topic, we'll look at different types of wave, transverse wave and longitudinal wave. Then we'll also look at some terms associated with wave motion, and then solve some problems, some basic questions on wave motion. So that is what we are going to cover in this particular aspect. Subsequent one will deal with other areas of wave motion. Okay, so if you are ready, let's go straight to the class for today. Alright, so what is wave, or what is a wave? Simply put, a wave is a disturbance which travels through a medium, transferring energy from one point to another without causing any permanent displacement of the medium. Okay, so that is a wave, and you can experience it if you agitate a water body. So if a water body is calm and you throw a stone on it, from the point where the stone lands on the water, you see ripples of water will spread out. Depending on the shape of the stone, if the stone is circular, or if the object that landed on the water is circular or maybe straight, the wave that we generate will look like the shape of the particular object that landed on the water. So you see the disturbance on the medium, okay, without you permanently displacing the water, because the water will remain the way it is, but you will see the disturbance of the water that spreads out from the point of the disturbance. So that is just what wave is all about. All right, so wave motion. A wave motion is a process of transferring a disturbance in the form of kinetic energy from one point to another in a medium without any transfer of particles of the medium. That is exactly what I just said now. The water particles will not be transferred, but you will see that the water body will be agitated, right? So, e.g., when a stone is thrown into water, circular waves are formed which moves outward from the point of disturbance. Similarly, when a string or rope is stretched straight on a table and one end is vibrated, wave will travel along the rope, um, along the rope. Okay, wave will travel along the rope. So this is supposed to be rope. Then wave will travel along the rope. Okay, so the rope and water above are known as material medium. Okay? They are known as material medium. So waves that require material medium for their propagation are known as mechanical waves. So example of mechanical waves: one, we have water wave, we have sound waves, then we have the one that we just mentioned now, wave on a string or rope. Then wave that does not require material medium for their propagation are known as electromagnetic waves. So example of electromagnetic waves are, we have light waves, we have radio waves, we have infrared, and all those waves are known as electromagnetic wave, and they do not require material medium for their propagation. Okay, they do not require material medium for their propagation. Right, so for you to demonstrate generation of wave, there's a piece of equipment that is actually used in the laboratory. It is called the Ripple tank. So with the aid of the Ripple tank and an instrument that is called a stroboscope, you can actually observe the wave generated in a tank, right? You can observe wave generated in a tank. Okay, so that is what is used to um, generate waves in the laboratory. Okay, so having that said, we'll look at a waveform and then some terms that are associated with the wave. That's what we want to study now. Okay, so this drawing here represents a typical waveform. Okay, this represents typical waveform. So this is the direction of vibration, this direction of vibration, and then this is the direction of propagation of the wave. Now if you look at this drawing that is here, you see that this is a crest, this is a crest, and then this is a crest. This is a trough, this is a trough, and this is a trough. Okay, so the distance between two crests, from the middle of one crest to the middle of the next crest, is known as a wavelength. The same thing, to the distance between the middle of one trough to the middle of one trough is also known as a wavelength. Then the height of displacement from rest, that is the distance from this point to this point, is known as the amplitude. Okay, so these are some of the terms that are associated or that are used to describe a wave. Terms that are used to describe one, phase. If you look at this drawing very well, you see that point A, point B, and point B, and point C, they are almost at the same distance apart. So particles that are at the same vertical distance from rest are said to be in phase. So like A, B, C, they are said to be in the same phase. Okay, then a circle. One circle is one complete revolution, or one complete to and fro movement. So a circle, this is a complete to and fro movement or oscillation of a vibrating particle. So if you look at this drawing very well, see that from this point down to this point is one circle. From this point to this point again is another circle. This point to this point is another circle. So like this particular wave that I drew now has 3 circles on it. So this is a wave that has 3 circles on it. So that is how you can use this. That is how you can measure the number of oscillations of a wave, depending on the equation that you are given. That okay? The amplitude of a wave, amplitude A. This is the maximum displacement of the particle from its rest position. The unit of amplitude is in meter, and that is what I just discussed here before. This is the amplitude of the wave. Then wavelength. This is the distance between two successive crests or troughs of a wave, and I've already mentioned that before. Okay, distance between two successive crests or two successive troughs is known as wavelength. Frequency. This is the number of cycles or oscillation a particle makes in 1 second. Okay, number of oscillation per second is known as frequency. Then the period of the wave. Period of the wave. This is the time taken by a particle to make a complete oscillation. The period of the wave is time taken by a particle to make a complete oscillation, and the unit is seconds. The unit of frequency is a hertz or per seconds. Hertz or per seconds. Okay, then wave speed. Wave speed is the distance covered by the wave per second. Okay, the distance covered by the wave per second is known as wave speed. Those are some of the terms that are used to describe a wave motion. So we'll look at how most of these terms are related to one another. So we're looking at some of the wave equations. Wave equations. So from our wave equation, we have that the period of the wave is equals to the time taken all over number of oscillations. Okay, so that is period is equals to t over small n, right? And frequency, a number of oscillation per time. Okay, so if you look at these two equations, you find out that they are related. So period is equal to the reciprocal of frequency, and also frequency is equal to the reciprocal of period, as the case may be. Then the speed of a wave is equal to distance traveled by the wave, or the wavelength of the wave all over time taken. So speed of a wave is equals to this, and or equals to lambda f. So speed of a wave is equals to wavelength times frequency. So basically, these are some of the equations that we are talking about a wave motion. And these are some of the equations that you come across, and we use them to solve different problems in wave motion. Okay, so we'll look at various types of wave before we solve some problems on wave motion. So we have a progressive wave, and for progressive wave we have two types. So a progressive wave is a wave that transfer energy in traveling or moving away from the source of disturbance. Okay, so that is a progressive wave. So we have two types of progressive wave. We have a transverse wave and longitudinal wave. We have transverse wave and longitudinal wave. So what is a transverse wave? A transverse wave is a wave that travels perpendicularly to the direction of the vibration producing the wave. So if you look at this particular wave, you see that this is the direction that is producing the wave, then this is the direction of travel. So this direction of travel is perpendicular to the direction of the vibration. So any wave that has this characteristics is known as a transverse wave. So example of this type of wave is water wave, light wave, radio waves, or waves in ropes and strings. So if you look at this wave, you see that here vibration is vertical while direction of motion is horizontal. So the direction of motion is perpendicular to the direction of vibration. So this is an example of a transverse wave, and we have given the examples: water wave, light waves, and radio waves. Is that okay? Then longitudinal wave. These are waves that travel in a direction that is parallel to the vibration of the medium. So example of this one is vibration of a stretched spring, sound waves, vibrating tuning fork, or vibration of drum skin. So if you look at this wave, you see that the direction of travel is parallel to the direction of displacement. If displacement is in this direction, and this is also the direction of travel. So any wave that behaves in this manner is known as longitudinal wave, and this wave is characterized by a series of rarefaction and compression. So this is a compression, this is a rarefaction, this is another compression, this is a rarefaction. So any wave that is described in this manner is known as a longitudinal wave. So see the difference between the two, longitudinal wave and transverse. You see the shape of their motion. Is that okay? So these are examples of transverse of a longitudinal wave. All right. Other type of wave that we just mentioned before are electromagnetic waves. Now these waves are waves of higher frequencies. So they have different types of wavelengths, and they have higher frequencies. So we have waves like radio waves, infrared waves, light waves, UV rays. All these type of waves are known as electromagnetic waves because they have higher frequencies. They are known as electromagnetic wave. Okay. So this is the difference between transverse and longitudinal waves. Longitudinal waves in longitudinal waves, the particle of the medium oscillate in the direction of wave movement. We've mentioned that before. Longitudinal waves are made of rarefaction and compressions. An example of them is sound wave. That's what we just discussed before. The transverse wave, the particles of the medium oscillate in a direction perpendicular to the wave movement. That was what we said before. Then it is made up of crests and troughs. Example is a light wave. Okay, so this is just like a summary page of what we have discussed before about longitudinal wave and transverse wave. Okay, so this is a sample question that we need to look at as we discuss wave. So this one says that the frequency of a vibrating source is 450 Hz, and the velocity of the sound it produces in air is 330 meters per second. Find how far the sound travels when the source completes 50 oscillations. Find how far the sound travels when the source completes 50 oscillations. So in this particular question, you are given you have been given frequency for this question. Frequency is given to you to be 450 Hz. Okay, so this is your frequency that has been given to you. Then you are given the velocity of sound to be 330 meters per second, and then you are given number of oscillation n to be equal to 50. N is equals to 50. Okay, so if you look at the equation of wave motion, you find that frequency is given by frequency is equals to n over t. Okay, frequency is given by n over t. So if you want to find the time to complete the 50 oscillation, to be t will be equals to n over f. Okay, so if you do that simple substitution, you have n is 50 and f is equals to 450 Hz. 450. So by the time you do this simple cancellation, you have that the time to complete that 50 oscillation is 1 over 9 seconds. Okay, the time to complete this 50 oscillation is equals to 1 over 9 seconds. So here you are asked to find the distance the sound will travel. It has to find distance, and we know that velocity is equals to what? Distance or wavelength all over time. Is that not? So distance is equals to velocity times time. So if we substitute into this equation, we are going to have that velocity is 330 and the time is equals to 1 over 9 seconds. So we can actually work this out. If you work this out, you are going to have, punch it in your calculator, so you have this as your results. So the distance the sound or the wave will travel will be equals to 36.67 meters. Okay, so you see how I related this equation of for frequency to velocity. Is that okay? So equations or calculations in wave, they are not that hard, they are simple. It's just for you to understand the variables that are given and then what you are looking for, then which of the equations you can use in order to solve your problem and get your answers readily. Okay, so let's go straight to another question. Okay, this one says a radio station broadcasts at a frequency of 400 kilohertz. If the speed of the wave is 3 times 10 raised to 8 meters per second, calculate the wavelength of the radio wave. Okay, so here you are given frequency to be 400 kilohertz. So what you should know is that you have to convert this kilohertz to hertz, right? You have to convert this kilohertz to hertz. So by multiplying it by 1000. So if you multiply this by 1000, if you multiply this by 1000, it will convert to hertz. So and that will give you 4.0 times 10 raised to power 5 hertz. I hope that is clear. You have to convert the kilohertz to hertz. Then after you've done that, you are giving the speed of the wave to be equals to 3 times 10 raised to power 8 meters per second. What are you asked to find? You are asked to find wavelength lambda. Okay, so from our wave equation we had that velocity is equals to lambda f. So lambda will be equals to what? V over lambda will be equals to what? V over f. So just substitute these informations into this equation so that you have V is equals to 3 times 10 raised to power 8 all over f, which is 4.0 times 10 raised to power 5. Okay, so by the time you work this out, you have that lambda is equals to 7.5 times 10 raised to power 2 meters. Alright, so this is what you have, or you can just write it out fully. That is 750 meters. Okay, so this is what you will have. So you see how to use the equation to solve the problem. Depending on the equation you are giving, just know which equation to use and then your answer will come out readily. Let's take one more. So this is another one that I want to take. This one says a radio station broadcasts at a frequency of 300 kilohertz. We already heard about kilohertz before, so this kilohertz just convert it to hertz, right? I'm multiplying this by 1000. If the speed of the wave is 3 times 10 to the power 8 meters per second, calculate the period and wavelength of the wave. Okay, so here frequency has been given to you to be 300 kilohertz. So as we did in the previous one, multiply it by 1000 so that you will have so that you should multiply it by 1000. Okay, so let me just do that. Okay, so you will have 3.0 times 10 raised to the power 5 hertz. Okay, so this gives you your frequency in hertz. Then you are also giving velocity to be equals to what? It's equals to 3 times 10 raised to the power 8 meters per second. Now you are asked to find the period. You are asked to find T period, and you also asked to find wavelength lambda. These two variables are what you are asked to look for. Okay, period. And so from our wave equation, we had that period is equals to the reciprocal of frequency. So just substitute into this one. So your period is 1 all over 3 times 10 raised to the power 5. So by the time you calculate that, you will have your period. So when you work that out, you have period is equal to 3.3 times 10 raised to the power minus 6 seconds. Okay, so this will be your period. Sorry about that. Okay, so I have 3.3 times 10 to the power minus 6. That's period. Then you have to find wavelength. Okay, so we had our wavelength is equals to velocity is lambda f, and then wavelength is equals to velocity all over frequency. So we can just do that the way we did previously, times 10 raised to the power 8, which is velocity, all over frequency, which is 3.0 times 10 raised to the power 5 times 10 raised to the power 5. So when you finish this calculation, you have that your wavelength is equals to 1000 meters. Okay, so I think these are pretty simple, and I think most of the questions, this is how they come. All these questions that we just discussed, they are all JAMB questions. So that's okay. They are JAMB questions and some are wire questions. So this is how they come. They are not. They just vary. They will just vary the questions. So, but this is how they come generally. So if you can master this, then there's no question that you will not be able to solve. All right. So thank you so much. We'll go straight to your test page. So this is test your understanding. Please try your hands on this question. Check your textbooks. Like if you have new school physics, check it. If you have lambda physics, check it. You will see some questions on this that you're able to solve, so that you sharpen and then get more understanding of this particular question. This one say a periodic pulse travels a distance of 20 meters in 1 second. If its frequency is 2.0 times 10 to the power 3 Hz, calculate the wavelength. So from here, you should know that you have to first of all calculate what? Velocity. Once you know the velocity, then you can solve for your wavelength. Is that okay? This is a wavelength 0.3 meter travels 900 meters in 3.0 seconds. Calculate its frequency. So here you have a wavelength, right? You have a distance, you have time, you don't have velocity. So the same thing, you find velocity, from there you can also for frequency. So I've just given you the hint, right, so that you would know exactly how to approach questions like this. Okay, so thank you so much for your time. So once again, thank you for your time. We appreciate you for staying with us thus far. This is Nobleman Science Tutors Online, and as I've always said, we are paused to make physics to be as simple to you as possible. So please, if you are not subscribed to our channel, what are you waiting for? Subscribe to our channel, click on the notification bell so that whenever we upload a new video, YouTube will notify you. You can reach us through the WhatsApp number that is showing right on your screen. So thank you so much. We wish you the best, and we hope to see you in our next class. Thanks.